Okay, so in today's video we're going to have a look at equivalent ratios. There's quite a few topics that you need to be aware of and be quite happy with before you start on this topic, one of those being algebraic fractions and the other being factorising quadratics and some of those harder quadratics. What I'll do is I'll link in the description the videos for all of those topics, so make sure that you are quite happy with those before you get started. We're going to explain why that you need to know those and obviously how this topic actually works. So we're going to kickstart with this question, so grab a piece of paper, grab a pen, make some notes, and let's have a look at this question here. So it says, given that 2x plus 4 to x plus 2 is equal to 3x plus 5 to x plus 4, find the possible values of x. Now we're going to use quite a simple bit of maths to actually understand why we're going to write this in a different way, but if we think about a little basic ratio such as 1 to 2, and think about a ratio that is equivalent to or equal to. So the most simple ratio I can think of is 2 to 4. So if we say that 1 to 2 is equal to 2 to 4, we've made a correct and true statement there. Now there's another way that we can actually write this. Now what we can actually do is look at the ratio as a fraction instead. Now obviously each piece of the ratio there, just looking at that one on the left, 1 would be 1/3 and 2 would be 2/3, but we're going to write it in a different way. So I'm going to take the left one, stick it on top, I'm going to take the right one, I'm going to stick it on bottom. There we go, so 1/2. Now neither of those pieces there are a half, but if I just rewrite it as a half, it's going to help just to explain how I'm going to approach this question. Now if I do the same with the one on the right there, so the left number on the top, so 2 on the top, and the right number on the bottom, over 4, and I have 1/2 is equal to 2/4. Now obviously hopefully you can spot that actually if we simplify 2/4 we do get 1/2, so we've got a half is equal to a half, and again that makes a correct and true statement. Now we're going to take this approach for the algebraic method. So if we look at what we've got on at the top here, the left one is 2x plus 4, so let's stick that on the top, so 2x plus 4 over what's on the right there, x plus 2. And that has to be equal to, just like our fraction over here, 1/2 being equal to 2/4, that has to be equal to 3x plus 5 on the top, over, and on the right there, x plus 4. So thinking about our very simple method here, saying that obviously 1 to 2 to 2 to 4 is equal to 1/2 to 2/4, that's allowed us to take this algebraic question, which is a lot trickier and looks a lot nastier, and actually make another correct and true statement. Now we've got it as an equation, we can actually go about solving it. Okay, so we couldn't actually solve it while it was written in a ratio, but now it's written as an algebraic fraction, we can actually go about solving this. So thinking about algebraic fractions and what we do when we have an equal sign in between them, we need to think about cross multiplying and getting rid of these denominators because we can't solve it while they're fractions. So in order to do that, and again do make sure that you're hot on your algebraic fractions here, but we're going to times both sides by the x plus 2, which is going to slot the x plus 2 over here on the numerator, and we're going to multiply both sides at the same time by the x plus 4, which will slot the x plus 4 up onto the numerator just there. So if we have a look at what we've got on the left, we've got x plus 4 now being multiplied by the 2x plus 4, which I'll slot into a bracket. And on the right, we've got that equal to the 3x plus 5 getting multiplied by the x plus 2. There we go, and obviously it doesn't matter what order I've written them in there. I've obviously just opted to put them where I drew the arrows there, just to sort of make it look a bit neater, but they could go in either order. Okay, so there we go, now we've got a double bracket on each side. Well, we've got double brackets, we need to expand them. So if we expand this one on the left, we get x times 2x, which is 2x squared, multiplied by, we've got x times 4, which is 4x, and 4 times the 2x, which is 8x. So combining them, 4x and 8x gives us a 12x. You don't have to skip the step there, you could write it out, but I'm just going to avoid, I might make an extra lines if I don't need to. And then we've also got 4 times 4, which gives us 16. There we go, and that's our double bracket on the left. On the right, 3x times x is 3x squared. Then we've got 3x times 2, which is 6x, and the 5x there, and 6 and 5 makes 11, so we have plus 11x in the middle. And 5 times 2 makes 10 at the end, there we go, so plus 10. Right, so now we've got a quadratic equation that we need to solve, no fractions involved anymore, so we need to make it equal 0. So to make this equal 0, I'm going to move everything to the right hand side there, purely based on the fact that we have a 2x squared on the left, so to avoid having a negative x squared, I'm just going to move them all to the right hand side. So we've got 0 here is going to equal, so we'll take away 2x squared from both sides, so that reduces my 3x squared down to a 1x squared. Take away this 12x from both sides, that reduces my 11x down to a negative 1x, so I'll just write minus x for that. And then taking away 16 from both sides will reduce my 10 to negative 6, there we go, now it's all equal to 0, and you can feel free to rewrite that equals 0 on the right hand side if you prefer it being there, but you don't have to. Okay, so there we go, we'll just write that on the right. Right, okay, so now we've got a quadratic. We need to solve this, figure out what the values of x are. So if I bring that up here, what have we got? We've got x squared minus x minus 6, and that equals 0. So we'll get our factors of 6. We can have 1 and 6, or 2 and 3. Here's where our factorizing quadratics is getting involved. Let's just rewrite that 3. There we go. Right, so we want to make -1 in the middle. So let's think about our brackets. So we've got x in both brackets. Okay, it's playing up a little bit. Let's just redo that. So x in both brackets. There we go. And to make -1, 1 and 6 isn't going to work, but we can have 2 and 3. So we can have +2 and -3, that makes -1 in the middle, and we get our two solutions there. For the first bracket we get x is equal to -2, and for the right bracket we get x is equal to +3, so I'll just write 3 there. Right, and there we go. So lots going on. Obviously taking that question to a sort of a new level there, we've got changing it into an algebraic fraction equation. Cross multiplying to get our double brackets, so we've got expanding double brackets, and then we've got rearranging to form and solve a quadratic, and then actually obviously getting our solution to that quadratic. So there's lots of different topics going on in there. Again, I will link in the description all the videos to all the little elements going on in this question, but that is how you approach these equivalent ratios when we've got algebraic pieces involved. So you're going to have a go at a question, so obviously watch back through that if you're not too sure, because there's quite a lot of maths going on there, but go back, watch that question again if you have to, but here is one for you to have a go at. So here's your question, so pause the video there, have a go, and we'll go over the answers in a sec. Right, okay, so we've got some slightly different pieces going on. We've got some negatives in here. So for the first one, if we create our fraction, we've got x plus 2 over 3x minus 2. And that is going to be equal to x minus 1 over 2x minus 3. There we go. Right, so let's cross multiply. So we'll times our denominators up here. And we get x plus 2, 2x minus 3. And on the other side, that's equal to x minus 1 and 3x minus 2. There we go. So let's expand that. So on the left here, we get 2x squared. We've got minus 3x plus 4x, that's plus 1x. And then 2 times -3 gives us -6. There we go. And expanding on the right, we get 3x squared. We've got minus 2x minus 3x, so that's minus 5x. And then -2 times -1, it gives us plus 2 at the end. Okay, so rearranging that now to make it equal 0. Again, I'm going to get rid of this 2x squared, so we'll have 0 on the left. And that's going to equal 1x squared over here when we take away the 2. We're going to minus 1x from both sides, so that gives me minus 6x there in the middle. And we're going to add 6 to both sides, so that gives me 8 at the end just there. There we go, so plus 8. So let's put that into double brackets. Okay, there we go. So our factors of 8 can be 1 and 8, or they can be 2 and 4. 2 and 4 is going to allow us to make 6. So we want minus 6, so we'll have minus 2 and minus 4. And there we go, we get our two solutions. So in our first bracket there, the x minus 2, we get x equals positive 2. And for our bracket on the right, we've got x minus 4 in the bracket. So for that, x equals positive 4. There we go, and there are our two possible values that x can have in this question, x equals 2 and x equals 4. Right, okay, let's have a look at something slightly trickier where our factorising is just slightly nastier in the question. Okay, so this one doesn't look very nice at all. Let's just follow all these same steps and see where it gets a little trickier in the question. So to start with, it's all going to be quite nice, hopefully not too nasty in the starting parts. So creating our fraction, we get 3x plus 7 over 4 minus x. And that is equal to 5 minus 3x over 9 minus x. There we go. Right, so again, cross multiplying. Hopefully you can see that these pieces here are just slightly rearranged. We've got the x on the end there. So let's just cross multiply and see what we get. So we get 3x plus 7 and 9 minus x. And that is equal to 5 minus 3x, and in the other bracket 4 minus x. There we go. And let's expand that. Got to be careful with a couple of these, but let's just see what we get to start with. So 3x times 9, I'm going to follow my normal order. That gives me 27x. 3x times negative x gives me minus 3x squared. 7 times 9 gives me positive 63. And then 7 times negative x is negative 7x. There we are. I am going to take this one a little bit slower than the last few. So that is equal to 5 times 4 gives us 20. 5 times minus x gives me minus 5x. Negative 3x times 4 is negative 12x. And negative 3x times the negative x there gives me positive 3x squared. There we go. Right, okay, so let's simplify this down a bit because we've got a few horrible little pieces there. So I'm going to write the minus 3x squared to start with. So we've got minus 3x squared. We've got 27x minus the 7x, so that'll leave me with positive 20x. And then we've got the plus 63. And that is equal to, we've got the 3x squared there, so I'll put that at the start, so 3x squared. We've got minus 5x and minus 12x, that makes minus 17x. And then we've got the plus 20 there, so plus 20. There we go. So making this equal to 0, obviously avoiding that negative 3x squared over there, so I'm going to move everything to the right again, so I'm going to add the 3x squared to both sides. So we're going to have 0 is equal to, and we'll get 6x squared there when we add it over. I'm going to do the x's next, so that's minus the 20x from that minus 17x, that gives us minus 37x. And there we go. And let's minus 63 from both sides, and that will give me minus 43. There we go, so this isn't going to be very nice. So I'm going to get rid of some of the working out now and just focus on actually factorising and solving this, just so we have a little bit more space. In fact, if I move this, we'll probably have a bit more space up there. There we go, let's put it here. Right, so going about actually factorising this. Now obviously we've got a 6x squared there, so we've got a higher coefficient of x squared. So let's try something out. Let's just go for a 6x in one of our brackets and see if this works. There we go. Now factors are 43, what can we have? We can have 1 and 43, and that's actually it there, so there are only factors of 43. Right, I've just spotted actually this is definitely going to work because we can have 6 and 43, and we can have 43 take away 6 will give us our 37 there. We want negative 37, so we'll have positive 6 take away 43. So let's have a look. So plus 1 over here to make sure we get our plus 6, and minus 43 over here. There we go, and that'll factorise that for us. And again, do just obviously check out the Factorising Harder Quadratics video if you want to brush up on some of this factorising. But here we go. For the first bracket there, we get x is equal to positive 43 over 6. And for this one on the right, we get x is equal to negative 1. Right, there we go. So there are our two solutions. That was a very, very tricky one there. Some quite nasty factorising at the end, and you've got to be very, very careful with these double brackets. There was a lot of elements there where we could have made mistakes. Just little bits, even just like combining the x's over here, the minus 5 and the minus 12, and just making sure that you actually, you know, don't get that wrong in terms of your negative numbers. And little bits just like when you're expanding on the double brackets here, minus 3x times the minus x, and making sure that makes positive x 3x squared. Just all those little bits where you can make little mistakes. You've got to be super careful on these questions. But there you go, that's how you'd approach a nastier one, and here is one for you to have a go at. Okay, so here's your question. So pause the video there, have a go, and we'll go over the answer in a sec. Right, okay, so for this first one, let's have a look then. So we've got x plus 9 over 5x minus 1, and that's going to be equal to x plus 7 over 2x minus 3. Now hopefully you've already noticed that this one's a little bit easier than the one I went over last time, but still quite a difficult version of one of these questions. So let's cross multiply these and see what we get. So we're going to times this up here, and we're going to times that up there. Again, I always like to draw these little arrows in just to remind myself where everything's going so I don't get them mixed up. So x plus 9, and we get another bracket here, 2x minus 3, and that is going to be equal to x plus 7 5x minus 1. There we go. Right, so expanding this, let's see if I can jump a few steps when I'm doing this. So the first bracket there, we get 2x squared. We've got minus 6x plus 18. Right, so minus the 3x plus 18. Minus 3 plus 18 gives us positive 15, so plus 15x. Always just go back and double check that. Plus 18 minus 3, that gives us plus 15. And then we've got 9 times minus 3, which is minus 27. There we go. On to our next one. X times 5x gives us the 5x squared. Then we have minus 1x plus 35. So 35 take away 1 is 34, so plus 34x. And then 7 times minus 1 will give us minus 7. Right, okay, so again we're moving all the pieces to the right. We'll get rid of this 2x squared to start with. So 0 is going to be equal to 5x squared, take away the 2x squared is 3x squared. We've got minus 15x from both sides, so 34 take away 15 gives us 19, so plus 19x. So I just have to just go back and double check these quickly. 34 take away 15, yeah, that's 19. And then we're going to add 27 to both sides, so add 27 to minus 7 gives us plus 20. Right, okay, now 20's got quite a lot of factors, so let's have a look. Right, 1 and 20, 2 and 10, or we could have 4 and 5, so we've got quite a lot of options here. So we've got 0 is going to be equal to, and we've got to have a 3x in one of the brackets if we've got a 3x squared. Oh, don't want another 3x there we go, just x. And how we're going to make 19, let's have a think. 1's going to triple, so there we go, it's the 4 and the 5, we'll get 15 and 4. All positive, so that's quite nice, so plus 5 and plus 4. There we go, and we can get our two solutions then. So for that first bracket there, we get x is equal to negative 4 over 3. And for the right bracket there, we get x is equal to negative 5. And there we go, there's our two solutions. There we are, and that's our question done. Right, now I've got two more questions that we're going to have a look at. We're going to have a look at them separately, but let's have a look at those questions now. Okay, so well done if you've made it this far already, because these are quite tricky questions. There's a lot of algebra going on in these questions. Now we're going to start to explore two more increasing difficulty questions, but here's something that's just a little bit different. As you can probably see from the question, it looks different. We've got a number ratio on the right, we've got a ratio on the left that has an x squared in it, so it's already starting to look quite different. So I would encourage you just to sort of have a go, see what you get, and see what you can do with this sort of question. Obviously a little bit different to something that I've shown you, but pause the video there, have a go, and I'll go over the answer in a sec. Okay, so let's have a look then. So we've got x squared on the top and 3x plus 5 on the bottom. You can decide if you want to put that in a bracket or not. I'm going to keep it in a bracket. And then on the left there we've got 1 over 2. So again, we're just going to cross multiply. Doesn't really change anything that it's a number, it just makes our cross multiplication a little bit easier. So times the 2 up there, and we'll times the bracket up there, and that's even nicer because we're timesing it up to the 1. So times the 2 over to the x squared, and we get 2x squared, and that's going to be equal to 1 times that bracket, just gives us that bracket. So in fact I could take it out of the bracket now if I want. I could just put equals 3x plus 5, or 1 lot of 3x plus 5. Okay, so we can make this equal 0 now. For the first time here we can actually move everything to the left. So if I move everything to the left, we'll get 2x squared minus this 3x and minus this 5, and that now equals 0. And now we can go about actually factorising this one. So we've got a 2x squared in the bracket, so we know in our bracket we're going to have a 2x and an x, and the only factors we can have there are 1 and 5. So how are we going to make negative 3? Let's have a think. So we could have 5 and 2, that's going to work. So we want positive 2, so let's put our 1 over here, and negative 5. There we are, and that's going to allow us to have plus 2, take away 5, gives us that minus 3 in the middle there that we're looking for. Okay, so we've got our two solutions now in our brackets. So we have for the first bracket there, positive 5 divided by 2, so x equals 5 over 2, or 2.5, and for the bracket on the right there, x is equal to negative 1. And there we go, there's our two solutions and our possible values of x for this question. Right, there we go, well done if you got that. We're going to have a look at one more question in a different context, and let's have a look at that one now. Okay, so don't be put off by all the words. This question is in a very different context, but it is involving the skills that we've been looking at in this topic. So there are actually multiple different ways of solving this question, but I think following the process that we've looked at in that throughout this video, there's a really nice simple way of solving this particular question. So I'm going to get you to have a go at it, but I'm just going to sort of read a few bits out here and think about how we could create that. So it says there are R red counters and G green counters in a bag. A counter is taken at random. The probability that it is green is 3/7. And then it says a counter is put back in the bag, so nothing to do with when we're looking at probability here, and there's no denominators getting reduced, it's just the counters put back in the bag, and then we're having a look at something else. It says 2 more red counters and 3 more green counters are put in the bag. And then it says a counter is taken at random again, and the probability that it is green now is 6/13. Find the number of red counters and the number of green counters that were in the bag originally. So what you've got to think about here is how can you create some of these equivalent ratios in this particular question. So it is going to be using algebra. You are going to have to think about how you would equate some of these ratios, but have a go, see if you can create your equivalent ratios. If you can't, you could always just wait till I talk about the ratios and then just go about solving the actual equivalent ratios once I've written them down. But if you pause the video there, have a go, see what you get, and you can always have a look and see at the start of when I go over the answer. Okay, so let's have a think about how we create our equivalent ratio in this particular question. Now it says here the probability of green is 3/7. Now if that's 3 out of 7, there's obviously only red counters in the bag, so our red counters, the probability will be 4/7. And we can write that as a ratio to start with. So it doesn't matter what order we write these in. I'm going to write it as red to green, so I've just got to be careful in the positions that they go, but red is 4 and green is 3. So that's our current ratio at the moment. Now if we have a look at what's being sort of done to these counters, 2 more red are going in and 3 more green are going in. So we can actually create an algebraic expression for these now. Now obviously we don't know how many reds and greens there are, but we know it's in the ratio 4:3. So that could be 4x and 3x. Now if I sort of write that down here, let's have a look. We've got red and we've got green. I'm just going to leave a little bit of space here because I'm going to add a few little bits in, but we've got 4x and we've got 3x. Now it says that 2 more red counters are being put in, so that would be 4x plus 2, our new little ratio. And it says that 3 more green counters are put in, so that'd be 3x plus 3. So that there is our ratio once these counters have been put in the bag, 4x plus 2 to 3x plus 3. And it says that now we've got this probability here, and if we have a look at writing this probability like we did just here, red to green, we'll see what it is now. So red to green now, let's have a think. We've got green is 6/13, so that's going to be 6, and obviously red, our fraction for that, what's remaining from 6 to 13, that is 7, and that'd be 7/13. So our ratio of red to green would be 7:6. There we go, 7 reds and 6 greens in our ratio. So if we set that ratio down here, we've got red to green is now 7:6. That is after this change is made, so these are going to be equal. So we've got 4x plus 2 after we've added in 2 more reds to 3x plus 3 after we've added in 3 more greens is equal to the ratio 7:6, obviously given by our probability that we were given down here after the counters are added in 6/13. So now we've got to this point and got our equivalent ratios, we can just take exactly the same approach we have in the entire video. So obviously if you didn't quite get that little ratio part, you can at least pause the video there and have a go at solving this now that I've shown you how to do it. So I'll give you a moment to pause the video, but we're going to go over the answers. So having a look at this then, we'll create our algebraic fraction. So we've got 4x plus 2 over 3x plus 3, and that is equal to 7/6. Now I've got quite a big multiplication to do here, obviously, because we're timesing by 6 and we're timesing by 7. We're going to times the 6 up here, and we're going to times the 3x plus 3 up here to the 7, and let's see what we get there. So we get 6 lots of 4x plus 2. Now I'm not going to write that as a single bracket, although I could write 6 brackets 4x plus 2. I'm just going to times them both by 6. So obviously you've just got to be careful that you remember to times it by both these pieces. So 4x times 6 is 24x. And 2 times 6 is 12, so 24x plus 12, and that is equal to 3x times 7 is 21x, and 3 times 7 is 21. There we go. So actually this is quite nice because we don't even have a quadratic equation now, we just have a nice linear equation to solve. So if we take away the smallest value of x from both sides, so the 21, that leaves us with 3x over here. And let's take away the 12 from both sides so that our numbers are over there on the right hand side, and that leaves us with 9. There we go, 21 take away 12 is 9. So we get 3x equals 9, and there we go, x must equal 3. There we go, so x equals 3. Now let's just get rid of some of this because this is obviously not our final answer here, because the question down below has said Find the number, let's just highlight this, find the number of red counters and the number of green counters that were in the bag originally. So originally, let's have a look, we had 3x for our green counters and our red was 4x. So red to green was 4x to 3x. Now let's have a look, we found out that x is equal to 3, so 4x would be equal to 4 times 3, which is 12, and 3x would be equal to 3 times 3, which is 9. So we would have 12 to 9. Let's have a look in the bag originally. Okay, so we've got 12 that are red, and 9 equals green. There we go, so we have obviously 21 in total there, but 12 reds and 9 greens. And obviously you could even have a look at how many counters were in the bag after the ones were added in. So we had 2 more red put in, so obviously that would be 14 reds, and we had 3 more greens put in, so that would be 12 greens. Okay, but it said how many were in the bag originally. So there we go, red is 12, 9 is green, that's our final answer, and that's this question here, looking at a bit of equivalent ratios in a sort of different context. But there we go, that's the end of the video. Hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.